Everyone, good morning here to the FPGA live stream here of the more random live stuff, code work and IT news channel. So on yesterday's live stream I mentioned that probably I rather rewrite here some of the timing. If you're new to this channel, main channel with more main stuff, and there are all the details. If I go through all of them always, then stuff becomes a little bit long here. So this is the timing we inherited. Again, details previous videos there, main channel. And I wanted to fix this further, and I've done this already, although the video capture doesn't really give this justice. So I've rewritten what I meant yesterday. Previously the state machine was here like that. And I mentioned yesterday it probably makes sense to only have one counter, because as per yesterday's video, even the original example was counting X and Y position. And yesterday I mentioned, so not only did I yesterday fix the many off by ones due to the counting imbalance, actually also off by the whole back porch of the front sync back porch signal of the video timing, previous video there. And I mentioned it probably saves some logic cells here on the FPGA, only counting once, making this even more elegant and stuff. So I've just done this. So this is how the original code was looking, the original example. And this is the new code, just as I mentioned yesterday. So now we have some count. I also renamed this to, the original code had this, I think, counter like this. I always also, readable names. Everyone, of course, considers something else readable. To me, this CTR always looked like control, but yeah, so count, but whatever. Maybe in the, we will see if we leave it, probably we actually maybe leave it like this. Anyway, so this is the new counter. The original code was counting negatively, how you often do, initializing this here to the, the count to this state, according to the state, front porch, sync back porch of the timing signal of the VGA or other DVI code, and then counting this down here, count here, and again I only proof of concept did the horizontal work, and so this not only saves quite some logic elements. Original, I made a note here this morning, I started with 273 logic cells used, and now we are down to make iceproc. Let's save this here again. Now we are down to 163 or 62. However, I think the saving might be slightly more. I modified the signal generation a little bit, so probably use here 263. I think I was, so that, but even that is still 10 saved. And we will now save a couple of more, so live here on this channel. Let's do this together. Even with, so what I do now live on this channel to show you how this works is also convert the vertical portion of this video signal generation. And because as you see, this is still old-fashioned code. And also this code was still off by one in the X position, and I debugged this here a little bit with trial and error and stuff. I realized we never had an X position 0, so although the video capture doesn't fully pay this justice, because somehow this video actually, wait a second, now this is, as you see, this stupid Epiphan video capture dongle thing here of, can I even hold this into the camera without shorting something? Previous videos, binary only, garbage here of, also binary only. Theoretically, we also need to free this by open source writing a driver for this Epiphan capture dongle. Actually now, surprisingly, after restarting this, like power cycling this, this is now slightly stupid that, so now, because when I started the live stream, this was, actually, wait a second, now I moved this, and now, that is stupid, just the white. Anyway, there you see pixel precise capturing not. Because the issue is I mark the whole boundary, the border with x and y0 and v minus 1 and h minus 1 with white. And as you see, that doesn't capture precisely enough. We certainly could restart that. Let's see also, yeah, you see now that I toggle this and it actually, does it even recapture? Hello? No, it doesn't even. So much to restarting this. Oh, no, you see the white is there except when it disappears. So this is not showing on the monitor, so you can, the famous last words, you can trust me when the signal is correct. But anyway, so one more timing bit as per yesterday's notes, that this timing was off by a couple of back portion of the sync signal, and this still today was off by 1 in the x direction. Remember yesterday I had there starting with -1 or something. This trick is no longer needed, and it turned out that the signal, the data enable, was off by 1 also. There you see so many details. So how many geniuses does it require to write a pixel correct HDMI, DVI, VGA like output? The issue, because previously this was in an always positive edge clock block here, and I also changed this, probably saving another 2 or 3 logic cells previously. I can also show you how this looked previously. It's still in the picosoc code of ours. So picosoc video timing. So previously this was, as you probably see here, this was positive edge. So the issue with that is that again, these are non-blocking statements, so they they latch the signal at the positive edge of the clock, and then the signals update, the new H, sync and data enable stuff updates at the end of the clock cycle. And this is why even the old code, so mind you, so the old code was off by quite some, plus all the fixes still off by 1. And after Guru meditating over this, I figured that this signals update with a delay. So because they clock in here the state, and this means that we set the state here in here you see by the way the old code. So this state is updated at the end of this clock cycle, and this H, sync and data enable only update with a latency of 1, right? Because they, again, at the beginning of the clock cycle, all of those logic is evaluated, is like propagating through all the flip-flops there and logic cells, and then only 1 clock cycle later is this stuff here. Well, I mean, it's always, you see, it's clock with clock, but we generate the timing, we output this, and then only at the next clock cycle we update this. So this was also off by 1. So there you see how much this Verilog in blocking, non-blocking statement even apparently a little bit tricky, maybe even confuses the best of the best. But I now changed this to always assign this here. This even saves a couple of logic elements, because now we no longer have flip-flops here at FFs to buffer this and output this, and this like instantly updates always with updates to the signal. So they should be updated in sync because they are hardwired now. They are no longer clocked with a clock and updated with clock cycle, but they are hardwired to this states that not only fix the off by 1 issue for me, it also frees a few logic cells again, because no buffering and clocking and stuff. So let's update here the final thing as this to show you how this works. So you see, in my opinion, much cleaner code. How this works, the old code again yesterday, to summarize yesterday's video, pretty geniusly a tricky code here of a manually constructed rotate left for the next state here with this hard-coded wires to the bits of the state, and then depending on the state counters, loading the next and counting it down, of course, how you would do, except -2 for from -1, which we also do, of course, because this is including 0, so not from counting from 1, but 0 to n-1, as so often in computer science. But also -2, because I said this yesterday already, it also took me a while to figure out, because this is here until the overflow, so this is actually counting until -1 to easily, efficiently track the overflow. So this is again -2. Also, yeah, comments, said yesterday, the more comments the better. Welcome, Dietard, there in the audience. Thanks for tuning in. I hope you appreciate this FPGA goodness. So the new code, in my opinion, less tricky. The only tricky thing is using negative values, which so the way this is constructed, you see here, still counting down. Now we are not counting down, but counting up, and we are counting from minus. So I mapped this so here with, we have the timing portion, front porch, sync, back porch active. And do I even have a timing diagram? I thought I had this here somewhere. So we are counting from minus. So I made the whole portion of the timing portion of, could probably also open this with some good old Firefox. So all the timing signal portion is negative, so that we can directly use those counters for our frame buffer, sprite, text logic, and not have to waste any cycle and not any logic elements with additional counters. So again, I freed 10 logic elements. So again, here's this illustration, front porch, sync, back porch, active pixels. So in my counting, we are starting negative from here. So this is minus like 84, and then here minus 64, minus 18 something. The concrete values come here from this timing definition. So this is minus 80, then minus 64 more, so that is 144, and then 150, 160, I think. So from minus 160 and so on to the active area, directly allowing to use these counters. And I feared that this comparison here, so we have here comparators or comparisons of switching here a case block of which count are we at? Are we at minus the sync signal, then transition? So front porch, sync, back porch. So if we reach the sync, the next state. If we reach the back porch, the next state. If we reach, this is -1, because we always again one cycle update here, signal propagation. So all of those are -1 for updating at 0, for example. This is why at -1 the next state is the next state, counting from 0, how you do it. And then again, this is not it's not a hack. It is just normal in computer science for counting at 0, 0, 1, 2, 2, 7, for example, or FF, something of that sort. So this is not a hack, that is normal, that is 0 to inclusive n-1. And then after all the active pixels here at h horizontal active -1, next state, I kept this neat state rotation stuff, and then this is negative here of 0 minus front porch, sync, and back porch. Works pretty neat, as you probably can see here also. Video capture, whatever, probably whatever, something. Let's see. Super appreciate actually considering buying an icebreaker board just to run this. Yeah, that sounds amazing. Yeah, leave me in the comments. Of course, there are other boards, icebreakers, just what Aston has probably next to run even bigger systems. Probably is. This is actually quite fun. So maybe actually a larger board sometime soon for me, I guess, with more logic elements for memory management unit and stereo deck. So anyway, let's convert this. Here the system is the same. So basically we can copy all of this stuff over, like theoretically probably like all of this, I guess, and just substitute. Here's, by the way, I thought I made some timing diagram somewhere, so also not there, but here you see this is the timing signal again, and what is it, by the way, the H rollover. Not really sure what that was doing. What was it actually doing? So that is positive previous state, Why do they need this? Not really sure actually. Can we do without that? Not really sure why they needed that. So yeah, we also need to update this here a little bit. So right now this was dynamically computing this, which is quite neat, but a little bit annoying to wire the signals out, so no longer dynamically compute, or like dynamically at synthesis time. So this is also signed, just gives this, not really sure if we need this, probably we don't really need this. Register wire, so this is a state, rotate left. And then, so similar to H, so basically this is just substituting. Theoretically I could actually use the editor, substitute for that, but this few we can also for illustration purposes do manually. Also there's always a risk to miss one or two, which most likely famous last words, and then now we get some drop frames. So this, I'm not really sure why they needed this rollover thing, because to me this looks, why would they have this if rollover begin, why only, what is this rollover thing for? I'm not really sure. Maybe we need this after all, then we can revert this. So front, vertical front porch, then back porch stuff. Yeah, let's see if we need this. Do we need this this rollover thing somewhere? Not really sure. Also, yeah, famous last words, and then nearly forgotten here. Do we have any other horizontal? Yeah, you see, this is why you usually want to use an editor replace function for that. So then let's see, is used, what was that? I wish this would, or maybe I should actually check if this has some, this were just constraints, did it had some? I have the feeling most of the design might have been optimized away. Here's YPOS is used, wire, top YPOS is used but has no driver. Okay, YPOS is, because we saw XPOS, we of course need to assign this. I probably do another round of cleanups right now. This is of course just all over the place, replaced as needed. So if you also my Emacs is using another ident width, but yeah, whatever. Let's see. Let's suspend this shortly. And what are we getting at 245? So another 10 or so logic cells saved. Any warnings? I wish this had like a stop at warning stuff. Maybe I need to investigate the command options here. Did it flash? Not sure. Let's just rerun this and see on the capture. Let's see what we are getting, if anything. The only thing is I probably should write some test cases. I have the feeling we don't really get much signal, so much to that. What would this rollover have been? Oops, sorry, too many camera views. Could also use either this or... But anyway, right now we don't get signal. So maybe this was with the rollover. So what, oh wait a second, what are we initializing here? Okay, we actually start with 0 initialization. Right, this initial state is wrong because I start with active state for simplicity. Because otherwise, why do I do this? In my opinion, probably the IC, the lattice or ZIL or whatever HDMI transmitter doesn't care if we start whatever generating the signal. It is probably outputting either directly what we sent it, or it waits for the first clock edge anyway. In either way, if we would start with the signal here as sketched with the front porch, I would need to have this equation here with the initialization time, and I figured that is just too much code duplication. Let's just start with active pixels at 0, and then it will just, doesn't matter, it will sync in after a millisecond of signal anyway. This way we don't need to have this initialization of minus whatever pixels there. Let's see if that fixes this. I'm not really sure what they had this overflow thing for. Do we still not get signal? So probably next I should write a test case for this and run this over through Verilog to make sure that whenever we make changes we don't break something like that. Do we have? Probably not. Does it have? I'm not really sure what the... we can also reset this, does it? Let's see, this is a little bit easier with the display. Also, wait a second, did this video capture? Wait a second, also wrong. I have the feeling this video capture thing crashed so much too. Because I don't have the video capture device now anymore, so much to developing here live with video capture. Do we have some kernel? Oops, or no, not really. Here we have whatever sound. Yeah, Epiphan, or is it maybe actually one oops could be normal. Yeah, let's maybe quickly restart OBS and see if this capture device reappears. Again, this is inconvenient, so it's not only binary only, but yeah, like live capturing video signals that disappear and are off. So yeah, so much to this live capture. The device looks to be here, but whatever is wrong with that, I certainly could plug this into, but yeah, the limits of that should I... Because Linux shows this without an issue, just that OBS doesn't show it right now because also no, can't even select it. So VGT capture here. Yeah, okay. There's also no signal when plugged into the display, so that maybe I need to think what this horizontal overflow thing was used for. I hope you learned something anyway. Although it's not yet working, it's for sure just some logic conditional something there. And anyway, we saved quite some logic elements, made this code more readable in my opinion anyway. And so this is old code and this is a new code. Fixed all of the off by one or off by many issues I found. Saved on top of the already genius code here, especially this, I still in love with this rotate left here. Hardwired goodness. Yeah, I finish this certainly more fun with display that works without a fuzzy video capture. And then it's certainly time to move on to keyboard, mouse or whatever. As usual, leave me in the comments below. Also, you could still vote PS2 80 keyboard versus USB, but probably we do the 80 keyboard, 80 style keyboard first. For the simplicity, USB is a little bit, yeah, but maybe, of course, USB more universal, useful for the system. Maybe we do it anyway, maybe first old-fashioned, good old serial protocol stuff, and then if that works, then we might turn to USB. In any case, thanks for watching, hope you learned something, and it inspires you to do hardware, software, and how to do things right. And also, yeah, the issue is, of course, I mean, if you publish something, best publish working stuff. The issue with this code is that the test output was hiding this issue. I said this yesterday already. Maybe the original authors have not even realized that this is off by so much, but also maybe lesson learned that probably should test this because they were generating some pattern. And whatever. Where am I even? This is also common. So DVI. Another lesson learned, really test this stuff because like also test as in, although this is my modified example already. So the original code was just outputting some test pattern like that. And the issue with that is that with that test pattern, you always see some colorful pattern and not if it's off by one. So a lesson learned maybe for you to play along at home. Output some synthetic signal here like I've done here with X, Y and 0 stuff like a white border, that you check that really the first and last pixel are clocked correctly, especially so you don't even need an expensive oscilloscope or logic analyzer, which even we don't have if you have only some old entry-level piece of garbage here, which for this I did not even pack out, I only unpacked it for the audio stuff. Even this, you don't need fancy gear, just be creative. Testing the first and last pixel is already quite some good thing. And let's see, do you think it would be feasible to adapt this code to drive an old school MDA monitor? Even VGA would work, so MDA probably, even VGA. So I saw other examples. If you use some resistors, you can directly drive from this, well, directly drive if you're feeling lucky for not destroying the output drivers of the FPGA. But this code again, because this is outputting the VGA code, so this should theoretically, if you attach resistors to those pins, at least there are other examples. I think this should even probably work. I guess maybe that would actually be fun. So there is also a ready-made PMOD for that, meaning PMOD to attach there for this universal PMOD standard thing. But you don't really need a PMOD, so theoretically some breadboard with some resistors probably should even give you VGA. No need for MDA or something. Of course, no color, because you have only TTL, so that would only give you full green, full blue, full red. So although probably maybe you actually need to modify the timing slightly, but in general we are outputting a VGA signal, so just with some modification in terms of resistors for the outputs, driving it with full level and probably timing divided by, what do we have? Timing divided by 12, I guess, or something, would even give you a VGA signal if you wanted. Yeah, MDA. So for MDA, I know that those is TTL. Also, you can drive MDA for MDA and stuff. You would need to change the timing more. I only meant to say, so if you modify this, you could adapt this to TTL displays of Amiga, Commodore, C64, MDA fame. But even, I meant to say, even modern displays and CRTs of VGA stuff, they would even work more directly with this code with only minimal modifications needed. For TTL you would modify a little bit more timing wise, but this would work if you can be made work if you wanted to. Yeah, that's it for today. Let me fix this last off by one, then I move it over to the RISC-V code and I push it to GitHub, and then you have the full example of even more precise timing. And then for the video output stage, actually one was always my habit of wanting to end the stream, and then one more thing. Yesterday I said here timing wise, I think to fix this fully, which also this is not my code in PicoSoc. Yesterday I wondered whether to change this text mode generation to output the output stages, not because right now we at position 0 we generate pixel 0, although we have like 2 clock timing delay for memory access, for first accessing the frame buffer and then accessing the font or sprite lookup. And I was wondering whether to change this to push those, like have some kind of first in, first out FIFO there on the output stage and make our lives a little bit easier. But the issue with that is that right now where is even I also loaded the wrong, yes, pixel clock. The issue with that is I think it might even become more complex, although it sounds easy of generating the pixel and pushing it down some FIFO. The issue is it doesn't work that easy, because if we load this, because we don't have the pixel, so at position, for example, X and Y 0, 0, we still have not the VRAM loaded. So it probably doesn't really make it easier, because you would still delay this loading, and then if you are 2 clock cycles further, you are already at position 2 and not 0, and only then would have loaded the VRAM. So in my opinion, this concept probably, although it sounds like easy to just somehow delay this in some pixel processing pipeline, I think for now I stick with this concept of preloading this VRAM just like we have done, so that at position -1, for example, each last pixel, and this is also why I changed this to this negative counting, because then at each 7th pixel, even if it is -1, it's still the 7th, like -1, we are loading, or actually not -1, but -4 and -2 and stuff. But to stick to this concept of preloading this, because then we have it easier or more natural for this bit shifting pattern here of the mask. And yeah, so probably I stick with this, but if you have, maybe I read more examples of FPGA Game Boy and other fancy FPGA code, but right now I still think it's probably because we have a timing signal X and Y position, and at this X and Y we want to generate the signal for this position, so probably preloading the data from the frame buffer, like one pixel or for example 1 pixel or 1 character glyph, preloading this and then keeping this output RGB computation at the pixel clock. It's probably the way to go, at least the most readable and most understandable probably, but if you have another opinion, leave in the comments below. It's just attaching nice Amber NDA monitor appears to me. Actually, it's a pity we don't have anymore. I had once, I got it even for free in 1990 or so from a school or something, when they have thrown an 8086 away. This is also, I said this in a previous video, I'm pretty well aware they have other address ranges. So even when I was like 10 or so and I got this, we had this cheap, like no name, like what was it, Oak or something, no name Oak, OAK or Oak VGA card. So on this 386 I had the second MDA card for debugging, second address range, and even when you were in VGA mode you could have your text debug output stuff, amazing stuff. I know what you mean, just that I don't have this display, I would need to buy it, so probably not. Although I'm tempted to buy an old-fashioned CRT. I somehow regret recently, a month ago, I could have picked up a really nice Sony Trinitron 21-inch CRT, like high-end 21-inch display for like €1 or maybe 10, because the winning bid was €1, I think. I actually should have bid like €10 and picked up some good old-fashioned CRT just for the retro vintage charm of it. But maybe next time I find such a CRT in Berlin, then maybe I should actually pick up a CRT. So anyway, that's it for today. I fix this off camera because, as usual, it's no fun to plug the cable back and forth and work here with this crashing or whatever disappeared here with my binary only. Also, yeah, famous last words, working with this binary only Linux driver, and since that's the famous last words of the stuff oopsing the kernel. But anyway, hope you learned something. See you next time. And as usual, looking for the comments also, keyboard, AT, PS2 versus USB and other fun stuff, or display, leave in the comments below, and hope to see you next time.